Alright class, video number 2. I was having such a good time with the first one, I figured why not one more. So here we go. Hopefully you guys are actually watching this, although if you're hearing me say that, then I know that you are. Anyways, alright, so here's problem number 2. Okay, alright, so looking at this one, tip number 1, look for Pythagorean identities. Okay, so maybe. But then I think I make this a little bit more complicated if I were to substitute in 1 minus cosine squared there. So I'm not going to do that. Tip number 2, write everything in terms of sine and cosine. All right, already done. All right, so now let's look at this one and think, all right, how about factoring? I got something squared and then a linear-ish term. You know, it's obviously sine x, so it's not linear, but a term squared and a term not squared. How about factoring? All right, so whenever we do problems like this, we got to set it equal to 0. And then we got to factor. All right, now this is a little bit weird. I'm asking you to factor using sines and cosines. All right, but if it helps you out, just kind of think of it as this: 2y squared plus y minus 1 equals 0, where instead of using y's, we're using sine x's. Okay, so it's really the same thing. So let's think about how we would factor this guy. Okay, so we got 2y in the front of one parenthesis, y in front of the other. This is negative, so we're going to have one positive and one negative, but I know I'm going to have ones in the back. So let's see, which one do I want to be negative? This one's going to get multiplied by 2. This one's just 1. So I want this one to be positive and this one to be negative. Let's double check. I know that the f and the l of the FOIL, which give me this term and this term, are going to be correct. So I just got to check the o and the I, the oi. So positive 2y minus y. Yep, that gives me positive y. Okay, so this idea over here should help me over here. So I'm going to have 2 sine x in the front minus 1, and then sine x plus 1 equals 0. All right, so now we're all factored. Remember, once we're factored, we can come up with these simpler equations. All right, so in this case, I'm going to have 2 sine x minus 1 equals 0, and then over here, sine x plus 1 equals 0. All right, so let's add 1 to both sides. Let's divide by 2. All right, now we got to try to find all the angles where when I take sine of that angle, I get 1/2. All right, so sine is the y-coordinates. On the unit circle, I need the y-coordinate to be positive. All right, so that's going to happen in quadrant 1 and quadrant 2. All right, where the y-coordinate is 1/2. All right, so hopefully throughout chapter 4, you're recognizing that both of these reference angles are going to be 30 degrees or pi over 6. All right, so this angle is pi over 6. That one's not so bad. But this angle, I know from the last test that we struggled with. It's almost pi, right? It's almost 180 degrees, but then we got to back up whatever that reference angle is. So we need to do pi minus pi over 6, because it's not quite a full pi. It's pi over 6 short of that. All right, so if you are struggling with fractions, like I know many of us do, remember you need a common denominator. So we rewrite pi as 6 pi over 6. We subtract 1 pi over 6, and we end up with 5 pi over 6. All right, and just like the last video, those are 2 of the solutions, but any angles that are coterminal with them. So we could add 2 pi as many times as we want. So wherever k is an integer. And same story here. Okay, so when x equals pi over 6 plus 2 pi k, those are all solutions. And when x equals 5 pi over 6 plus 2 pi k, those are infinite solutions. But we still got another equation, so let's go after this one. Sine x equals negative 1. So once again on the unit circle, sine is the y-coordinate. So where on the unit circle is the y-coordinate negative 1? Right there. Hopefully everyone knows that's 3 pi over 2 and all the angles that are coterminal. So we can add 2 pi k, add 2 pi k number of times. All right, and these are all of our solutions. All right, please note there's a difference between infinite solutions. You know, there are infinite solutions here, infinite solutions here, and infinite solutions here, but that doesn't mean all values for x are solutions. Okay, so there's an infinite number of solutions, but that doesn't mean all values are solutions. Okay, I totally understand if you guys are having trouble with tonight's homework, but please watch these videos again. You know, you can rewind and everything. Check out the examples in the book. Make sure you read, and please prepare good questions for class tomorrow. All right, guys, thanks a lot. Have a good one again. See ya.